Recycled glass fiber reinforced polymer composite incorporated in motor for improved mechanical performance. Thanks to author Harry Rodin and Somaya Carl Osama. The glass fiber reinforced polymer panel from retired wind turbine were recycled into a discrete structural element motor. Based on the 7 days testings out of the powder, small, medium and large size groups. The large group was identified as the optimum size due to the highest modulus of rupture. The overview of glass fiber. Glass fiber reinforcement polymer composites are being used in the different sectors: automobile, textile, windmill, aeronautics, medical applications. Among others, the wind energy sector is growing the industries with total 53 kilowatts global wind power. In the literature reviews, use of glass fiber, the light concrete is favored in many structural applications because of the reductions in dead loads. Glass fiber reinforcement polymers is relatively light compared to the raw material used in the manufacturing concrete, which can reduce the frost and hardened density when implemented as a replacement fine or coarse aggregate. The implementing glass fibers concrete influence mechanical properties of hardened concrete. Compressive strength does not always improve when implementing the recycled materials. Commonly due to the added weak linkage between the past and other constituents, the effective of recycled glass fiber when implemented easy comparisons. In most studies decline the report for but strength, the found additions 2% of super plasticizer as key contribution improvement strength. It is found by Ribeiro et al. In 2015. The methodologies of glass fibers, methodology of mechanical processing of glass fiber infopolymers. The GRP material is used in the study to produce the discrete structural element or rectangular panel from end of life wind turbine blade. This mechanical recycling process starts with the panel the first cut into the small rectangular pieces before being into a shared hammer mill. The several cut panels before shading the process can be seen in figure number 1. These are the tables, GRP replacement ratios, the powder, fiber, combo, effect and effective means appeared in the tables and their details. These are the, in this images figures is explained the examples of a glass fibers reinforcement polymer panel and the size large, medium, upper, these are shown in figures. Next one is a overview of two phases study. The experimental study was separated into 2 phases, with the phase 1 implement to find the performing of glass fiber reinforcement polymer size group. In this phases, all forces group of GRP replaced sand at the 3 placement volume constant size comparison. During the phase 1 and toughness index were evaluated to find the best performing glass fiber reinforcement polymer size group. In the phase 2, different volume fraction of GRP elements were compared using the most effective size group identified in the phase 1, phase 2. The GRP was implemented in the mixer design 1, 3 and 5% replacement of sand by volume. The mixers and GRP specification. The motor mixer using the MT company sand were implemented in the study. You can see the figure number 4. In the type 1 and type 2 Portland cements from Asgrow Cements company was used for phase 1. A water to cement ratios of 0.35 was used. The mixers designed for this phases of the project can be seen in figure table number 2. In this phase 2 was raised 0.40 created the more work mixers in table number 2. Regardless of increased, both mixers phases are produces 0 slump mixers measured by the minimum slump context test. The specimen preparation and testing. The specimen were cast specimen specificated as per ASM standard 305. The specimen were made using the standard benchmark mixers. The cement and water were added to bowl the first while the sand was added during the mixer. The glass fiber reinforcement elements were after the cements. The filled 50 millimeter cup were used as FC specimen and were attempted to constantly over the surface of the specimen during the two lift. The flexural prism wire 40 by 40 160 were also tampered evenly over the specimen surface and cast in the two lifts. Alkali silicates and reaction prism were cast 50 by 50 in 285 centimeters.